Hi dear students, so welcome back. Hope everything is fine. Okay, your studies are going on well. So let us continue motion in one dimension. Leave all the things behind. Okay, sit with the pen, paper or book, whatever you use. Okay, stop every distractions and sit in the class. Okay, so we have studied about distance, displacement, speed, velocity and acceleration, and we have done some problems also. Now we know what is the difference between displacement, distance, we know the difference between speed and velocity, and we have got clear idea about acceleration, and we have done some problems on average velocity and average speed, all these. Now before starting the next topic, we should get some mathematic fundamentals, then only we will be able to touch them. Okay, just like you have a nut and bolt screwed somewhere, so you need a tool, right? Spanner, and if you have a tool you can operate it, right? Or what? Same way, in order to deal with the next topic, we need a mathematical tool called calculus. Then only we will be able to deal the topic. So today's class we won't be discussing much physics, but we will be discussing completely maths. So once if you understand this session and next session, then we will be able to deal the further topics, and it is going to helpful throughout our physics. Okay, first thing which we will see is what is a function. What is a function? In mathematics, when we say a function, okay, it is like, just for understanding purpose, I shall show. If we give some input, okay, suppose if input is x, we call them arguments also. Okay, input is x, we will be getting an output y. So here this function is nothing but, when we say something is function in mathematics, that function will do some operation in mathematics, but actually in engineering also it will be performing some real operations. Say for example, this function f of x is equal to x square. This x is there, no? This x is nothing but the input, or we can say argument, nothing but x square. Suppose if we give a value 1 here, we will get an output 1. 1 square is 1. If we give an input 2, we will be getting an output 4. If we give 3, we will be getting an output 9. Okay, so this is square. This function is square. This can be anything. Say for example, f of x is equal to 2x plus 1. If this is a function, if we give these inputs here, we will be getting outputs like 2 into 1. 2 into 1 plus 1 is 3. If the input is 2, 2 into 2, 4 plus 1, 5. If it is 3, likewise accordingly. So we will give an input, we will be getting an output. This function is nothing but some operation. Okay, or it will do some function, that is the meaning. Okay, suppose when I say velocity, when I say velocity is a function of time, velocity is a function of time. Suppose velocity's value is given as t square. So function of time, then when we give 1 second, actually the velocity value will be 1 into 1 meter per second. When we give 2 second, velocity's value will be 2 square, that is 4 meter per second. So when we say velocity is a function of time, that means that based on time the value of velocity will change. Suppose if velocity v is equal to 4 meter per second, then this 4 doesn't have any t. That means this velocity is constant. Whatever time we give, 1 second or 2 second or 3 second, whatever time we give, in the sense at all the time the value of velocity is constant. Suppose if velocity is a function of time like a t square, it could be t cube or whatever it may be, it means that when time changes, the value of velocity is changing. That is, someone is accelerating or someone is increasing the velocity. Likewise, it can have different scenarios. Okay, so if something is variable means something is varying. So for that, what we say variable. Something that is varying is nothing but variable. Maybe temperature might be varying, so we can say temperature is a function of time. If temperature changes with the time, we call temperature is a function of time. Suppose if we are traveling, we came to know that temperature is increasing with the distance. So if we assume that x is a distance, suppose if we assume that x is a distance, suppose if you assume that x is distance, suppose if we assume that x is a distance, then if temperature increases with the distance, then we can say temperature is a function of time. How temperature changes with the distance, that we will have to analyze from the situation. Someone has analyzed, someone with the good knowledge on physics, someone with the good knowledge on mathematics, someone who is having practical knowledge went into the field and using thermometer, he took the reading, he took various readings and he did some mathematical calculations, and he came to know as we move further, temperature is changing as cube of the distance. So he may write T is equal to x cube. Q is equal to x cube. Say for example, if suppose temperature is changing with the time, temperature is increasing from morning to noon. If we are analyzing, temperature is increasing with the time. Someone analyzed it and he came to know it is like 2 into x square. It means 2 into t square. Clear or what? So here temperature is changing with the time, temperature is changing with the distance. How it is changing with the distance also we analyzed, we got that equation. How it is changing with the time, that also someone analyzed and we got it. Now if you substitute 1 meter, this will be the temperature. At a 2 meter, this will be the temperature. At a 2.5 meters, this will be the temperature. At a 1 second, this will be the temperature. At a 2 second, this will be the temperature. Likewise, we can have. So, function can be a function of 2 variables also. It can be a function of 2 variables. It can be a function of 3 variables. But we don't have that much complexity in our curriculum. 1 variable we have. Okay, 1 variable. Okay, so this is what is function. So any physical quantity that can be constant. Constant means no variable will come. T won't come, X won't come, nothing will come. Some physical quantity may be varying with respect to time, may be varying with respect to distance. Some physical quantity may vary with respect to temperature. So then that will be function of temperature. function of time, function of distance, function of temperature, anything. So generally we call f of x or f of t based on that. Mathematically we roughly say f of x. Those who have taken mathematics as a subject, you will be studying just as a variable f of x or f of t. We will not, when we study mathematics, we will not discuss about the physical quantities like velocity or temperature or whatever it may be. Simply the discussion will be based on some variables. But if you compare with the physics, it is very easy to understand and you will get a overview of the subject. So subject will become interesting. Learning mathematics will be interesting for you. Okay, so here when we draw a graph, why do we draw a graph? We draw a graph for better understanding. Say for example, if you draw like this, okay, so this is time axis. So this x axis is nothing but time, or I can say this is year. Okay, year. This is taken as 2010, 2020, 2030 year. Okay, that is given as in x axis, and in y axis revenue. Okay, revenue of a company. Revenue of a company. Suppose if you are running a company, or if your parents are running a company, if I am running a company, I am looking at the revenue. At 2010, how much revenue I got. Suppose if we write 10 and revenue I am writing in lakhs, and in 2020, okay, this is 20, 30 likewise. So when I analyzed at 2010, our company made 10 lakhs. At 2020, our company made around 19. At 2030, we made around this much. So likewise, we will be able to analyze well. Suppose if the same graph has this shape, same graph has got this shape, it shows the growth is again much more than this. Suppose if the graph has this shape, it means that initially growth was there, but later it started coming down. So rather than going through the data, rather than going through the number, if we get a graph, right away we will be able to comment that yeah, growth is there. Oh, too much growth. Arey, what happens now? Growth is very less. It is almost saturated. Just by looking at the figure, we will get the idea. Okay, so whole data for all these years, 30 years of time, it is not practically feasible to check all these. If a figure is there, we will get a better idea, right or what? So this is just a simple example I said. Now regarding physical quantities, scientific works, everything needs a graph and we will be analyzing it. So very important to deal with the graph. Okay, so when we deal with the graph, we will understand the need of mathematics to analyze all these physics. Now suppose this is x-axis and y-axis. If we draw a line like this, how you studied slope? You have studied slope in your 10th class also. Okay, so if you don't remember, I will tell you. Suppose if we take 2 points, okay, the angle here is theta. So this is also theta. So slope is nothing but how much this graph is like steady like this, or how much this is inclined to x-axis, how much this is inclined to y-axis. All this we will get from the slope. If some graph has zero slope, means it will be pakka horizontal line. So here slope is constant, here slope is 0. Slope is equal to 0. Slope is what actually? Slope is tan theta. Slope is nothing but tan theta. Suppose if this is x1, if this is x2, that is, if we take this point's x-axis is there at x2, y-axis is at y2. So this is the address of this point in this plane. With respect to x-axis, this is x2. With respect to y-axis, this is y2. And here this is x1 and this is y1. So I can say x1 comma y1. Clear or what? x1 comma y1. So x1 comma y1, x2 comma y2. This is the address of this point in this plane. This is the address of this point in this plane. If it is a three-dimensional, z also will come, but we don't study that, leave it. Okay, now here the slope is nothing but, actually the slope is nothing but y2 minus y1 divided by x2 minus x1. Okay, so or we can say slope is equal to tan theta is at, this is nothing but opposite side divided by adjacent side. So you have studied now, sin theta is equal to opposite side by hypotenuse, cos theta is equal to adjacent side by hypotenuse, tan theta is opposite side by adjacent side. So when I say opposite side by adjacent side, see this height is nothing but y2 and this height is nothing but y1. This length is nothing but x2 and this length is nothing but x1. Correct or what? So that is why we say opposite side by adjacent side, tan theta. So opposite side, how much is this length? How much is this length? y2 minus y1. y2 minus y1. Clear or what? And how much is this length? x2 minus x1. So opposite side is y2 minus y1 and adjacent side is x2 minus x1. Clear or what? So this is what is slope. Clear? So why do we study slope? Because by studying slope we will understand that how much that graph is inclined to x-axis, how much that graph is inclined towards y-axis. So this is nothing but actually slope is delta y by delta x. Clear? Note it down. Now why we are studying all this, we will analyze it. This is one graph, this is another graph. So this is y-axis, this is x-axis. So we did y2 minus y1 by x2 minus x1 and all. Suppose if this y-axis is nothing but it represents velocity, v meter per second. In mathematical language we just say y-axis and x-axis, but in this y-axis is not just for showing y-axis, it will be some physical quantities, maybe velocity or acceleration, or it can be any chemical quantities also, or biological, anything. Okay, it could be amount, cash, this could be time, year, anything. Okay, so just this axis is called y-axis, its axis is called x-axis. So if this is velocity and if this is time, if this is time, this x-axis represents times in seconds, then we will understand that this is how the velocity is. Suppose if we draw a graph like this, if I take this one like here, I will get like this. That graph is like this, which has more slope. This has more slope, this has less slope. Okay, so the one with the more slope is having more velocity. Suppose if we draw a line like this, this is time t is equal to 2 seconds. This value will be just 2. This value will be 5. So 5 meter per second, 2 meter per second. So at a time t is equal to 2 seconds, this graph shows if this is car A and this is car B, we can understand that at a time t is equal to 2 seconds, the velocity of car is 2 meter per second, velocity of car B is 5 meter per second. These are two different graphs, but we merged it and we are analyzing it. So I am telling very simple examples. Okay, the application of this thing is very huge. Okay, we are just started studying science and maths from +1. Okay, now we are telling very simple example, but this has got very complex analysis also can be done with using all these tools. Understood? So by seeing the slope, we will understand that the performance of something. Okay, now wait. So this is the importance of slope. Otherwise you will ask me, sir, why we are studying slope? What is the advantage? Generally the answer will be like we are studying slope for getting marks. It is not like that. It is not for getting marks. Marks will come, but the real necessity, the real need of studying slope is for this kind of analysis. Okay, clear? So this is of constant slope. Things are easy. Suppose yx, we got a graph like this. We got a graph like this. Now if we take two positions like when I took previously, if this is x1 comma y1, this is x2 comma y2. So in these kind of situations, when you try to study slope, you can observe that if this is theta here, at this position this is theta. If we take this position, this is what is theta. Which theta is higher, whether theta is increasing or not? This is small theta, this is small angle, this is bigger angle. Okay, so tan theta is increasing here, or we can say slope is increasing here. See, just by horizontal line I can analyze the theta at every point. Otherwise, how we will analyze? What we will do is we will draw a tangent towards this line, and here also we will draw a tangent towards this line and we will draw theta. If we draw a tangent like this, if we draw theta, likewise also we can analyze like whether theta is increasing or not. Okay, just by drawing a line. Clear or what? So here theta is increasing. Theta is increasing. I cannot simply find now slope is equal to y2 minus y1 by x2 minus x1. Simply I cannot find. This method can be applied only if it is a straight line. Only for straight line. This equation can be applied only for straight line. This is only for straight line. If it is not straight line, we cannot apply this equation. See, when you find area of circle, you will be using pi r square. To find area of square, we will be using how to find area? X square, length into length, rectangle length into breadth. So formula differs for different situations. Likewise, this formula is only for straight line. This is not a regular shape also. There is a bend is there. So we don't have direct formulas for finding these kind of curves. So what we do is, note it down. If a curve is like this, and if we need to find the slope of this, what we do is we will take very close points just like this, and we will take triangle very close. This will appear like a straight line. All these are straight lines for a close distance. This is also straight, everything is straight line. So when you zoom this, you will be getting a triangle, and theta x1 comma y1, x2 comma y2. So if we get like this, then again tan theta is equal to this distance. This is actually what? x2 x1, y2 y1. So this short distance, this is very close, the point 1 and point 2. Okay, point 1 and point 2, we say it tends to 0. It tends to 0, it becomes 0. Note it down everything. Okay, it tends to 0, or it is going to 0 but not 0. Tends to 0, not 0. We will take very short points, like it tends to become 0 but it is not 0, correct? So such short distance we take, such short distance are called as dy, and this distance is called as dx. So instead of saying x2 minus x1 or delta x delta y y2 minus y1, here this time we call dy by dx. Dy by dx. This is nothing but slope. This is nothing but slope. So dy by dx is nothing but slope. Why do we need slope? We need slope, just you understood the importance of finding slope. So to find the rate of change of anything is nothing but slope. Correct or what? So y-axis, x-axis. When we say dy, it is nothing but change from x1 to x2, that is change. From y1 to y2, it is change. Suppose if it is velocity and if it is time graph, then velocity becomes 3 meter per second to 10 meter per second. At what time? From when it is 3 second to 4 second. Suppose velocity of a car is 3 meter per second. At what time? At 2 seconds. When at 2 seconds we are observing, I told you now, we are observing some car. So at 9 o'clock 00 minutes and 2 seconds we started observing. So that is what? Here 0, 1, 2 second. Okay, 0, 1, 2 second. This 0 is nothing but 9 o'clock. 9 o'clock we started observing something. So at 2 second its velocity is something like 3 meter per second. And when we reach the 3 second, its velocity is somewhere like 10 meter per second. So 10 meter per second minus 3 meter per second is nothing but the change in velocity. So what is the time duration for that change in velocity? 3 minus 2. So rate of change of anything. Rate of change of anything means what? The speed with which something changes. Okay, it is very important to understand the change in which, the speed with which something changes. It is very important. Then only we will be able to do all the forecasting. Okay, very important in our life. So rate of change. So rate of change is what is slope. So when we write dy by dx, actually we are finding slope, or we are finding rate of change of something. Do you understand this? Clear? Hope this is clear. Now this short distance is called dy, this short distance is called dx. So the curves which doesn't have a constant slope or a varying slope, always we do dy by dx. This is called differentiation. This is called differentiation. Okay, this comes under calculus. Okay, differentiation. Differentiation, you can remember difference, differentiation. Okay, so already when they were constant values, we were able to put like y2 minus y1 by x2 minus x1, and when they were straight line. When they are not straight line, if it is some other curve, we do dy by dx. So whatever necessary for physics alone, we are studying here. How this dy by dx operates on different functions, how those values came, all these things you will study in detail in mathematics if you are a mathematics student. Okay, otherwise what we are doing is, see, when you take a washing machine, you put dry clothes, input, you put some powder, water, they are the input. It will process for some time, you take the clean clothes. Okay, so with the differentiation, what we are putting, differentiation formulas are there. Great mathematicians, they sit and they derived these formulas for analyzing their studies. Okay, two great scientists at different places developed this branch of mathematics for their works. They are not deriving mathematics just for the sake of mathematics. They will be doing some work, and in order to analyze their work, in order to study about their work, they might need a mathematical tool. Always they cannot spend whole time for analyzing. So they will understand, they will analyze, and they will find short time saving mathematical tools for their analysis. So they developed the mathematics. Sir Isaac Newton is also one among them. So he also developed this at a separate place, at a different place. Another scientist developed the same techniques sitting at a different place. So likewise, so this differentiation formulas are there, like each function. Say for example, suppose if some function is sine function, the shape of sine is this, sine wave is like this. So if it is a sine wave, then how to find the rate of change of whatever is there in y-axis with respect to x-axis? So we need to do what? There y is nothing but a function. Okay, I will write and show you. See, when I said if this is v, if this is t, this is x-axis, this is y-axis. When I write dy by dx, what I am really writing is dv by dt. So this v is nothing but a function. V is nothing but a function. We call them, mathematically we write function of x. Sometimes this is going to be function of time. When we write dv by dt, velocity is going to be a function of time. Okay, so velocity is going to be function of time. Okay, or velocity will be, this may be like t square plus 1 or something like that. So this velocity can be of any shape. Sometimes it may be parabola. It could be a parabola like this. So that time the equation of parabola is nothing but y is equal to kx square. So here y is nothing but v. So we write v. Kx square, any constant. It could be any constant. T is nothing. X is nothing but here t. So kt square. So suppose if we get v is equal to 2t square, then this is the function. This is the function. So we need to find the rate of change of velocity, which is nothing but acceleration. So when we need to find the rate of change of velocity, previously how you found acceleration in the previous class? A is equal to v2 minus v1 by t2 minus t1 or delta v by delta t. This is how we found acceleration. Clear or what? But here, how we will find acceleration when it is given as 2t square? So in these kind of cases, we will use differentiation formulas. So this is nothing but if velocity is a function of time, look here. So to find acceleration, we will be using dv by dt. Rate of change of velocity is what? Acceleration. Rate of change of velocity is nothing but dv by dt when the slope is varying. Okay, so hope you understood. Slope is nothing but a rate of change of something. So if y-axis is velocity and x-axis is time, then when we try to find the rate of change, or when you try to find slope, or slope is nothing but dv by dt. If y-axis is something, temperature, and x-axis is time t, then there the slope is nothing but rate of change of temperature. Okay, so rate of change is what slope is. Okay, change of something with respect to some other thing. Or maybe velocities, if velocity is changing with respect to distance, the velocity is changing with respect to distance. As we proceed with the distance, velocity is changing. So then that will be a function of distance also. So likewise, if something is varying with respect to another thing, temperature is varying with respect to time, velocity is varying with respect to distance, so that time we will be finding slope. So if the curve, if this has got different shapes, then this function will have different formulas, and function will have different names. So say for example, if a graph is like this, its name is nothing but, if this is theta, and if this is theta, then we call them sine theta. If this is y, we call them y is equal to sine theta. Then to find dy by dx, this is nothing but dy by d theta. Okay, here theta is varying, there x was varying, time will be varying. With respect to what it is varying, that will be the denominator we will have to put. Okay, dy by d theta, here d theta. What is y here? Y is nothing but sine theta. So this is tan theta. This has this thing, that is dy by dx of sine x. This, what is the answer of this? This the great mathematicians have derived. This derivation you will study in mathematics. I won't be discussing the derivations. I will be directly giving you the formulas. So with that formulas, we should be able to do the problems, and we will be able to deal the situations in physics. Okay, hope you understood why we are studying this, what slope is. Okay, so I will just summarize. If the slope is constant, we don't need differentiation, we don't need any calculus. But if the slope is varying, we need the help of differentiation and calculus. Okay, under calculus, differentiation is a part. Okay, why we are studying slope? Slope is nothing but rate of change of something, or change of something with respect to some variable. Okay, maybe with respect to time, or maybe with respect to distance, or with respect to temperature. Okay, to understand the change of something. Okay, to change of something. By understanding the change of something, only we will be able to analyze about that thing. So slope is important. So slope is nothing but tan theta, tangent of something. Okay, that is if it is straight line, y2 minus y1 by x2 minus x1. If it is not straight line, then that is nothing but dy by dx. Dy is the shortest points the distance between the shortest point. Dx is also the distance between shortest points. It becomes 0, it will not become 0, it tends to 0. So for things where the slopes are not constant, we have got specific formulas for different functions: sine function, exponential function, logarithmic function, algebra, polynomial. For all these we have the formulas of writing the slope, okay, or writing the when you differentiate something, we will get an answer, okay. So I am going to that. See, suppose if f of x is equal to x raised to n, if the function is f of x raised to n, in the place of n 2 can come, 3 can come, 4 can come. It can be square, or it can be cube, or it can be raised to 4. Then okay, d by dx of f of x, in short we put like f dash of x, differentiation of f of x with respect to x, in short we will write f dash of x. This is nothing but the formula is n x raised to n minus 1. Say for example, suppose if we get f of x is equal to 3x square, or leave x raised to 4, then f dash of x. F dash of x is what? Differentiation of f of x, differentiation of that function. F dash of x is nothing but n. What is n here? The power of x. Here it is 4. So write 4 into x raised to n minus 1. 4 minus 1. So this is nothing but 4x cube. Clear or what? So here nothing but df of x by dx is nothing but d by dx of, where it is, x raised to 4. X raised to 4 is nothing but 4x cube. This is the answer. Suppose, this is one example. Suppose if we get number 2, f of x is equal to what? 3x raised to 5. Then what is f dash of x? F dash of x means what actually? D by dx of f of x. This for easy purpose, for writing fast, instead of writing all this, we put just the f dash of x. Sometimes we call them f dot of x also. Okay, everything is fine. F dash of x is nothing but differentiation of f of x. So d by dx of what is a function? 3x raised to 5. So 3 is already there as coefficient. So put that 3 there. Don't disturb them. Put that 3 there. This is here. N is nothing but 5. Power of x is what is n. So here the power of x is 5. So that we will put where? Nx raised to n minus 1. So n, that is 5, into x raised to n minus 1 means 5 minus 1. So 3 into 5 is 15, x raised to 4. This is the answer. Clear or what? So here what we are doing? We got 3x raised to 5. 3x raised to 5 means it is not a straight line. How the appearance of x raised to 5? This video, if you want, you watch 3 or 4 times, nothing wrong, till these mathematical stuffs go into your head. Okay, look here. formula of straight line, y is equal to mx plus c. Suppose if you draw a graph and if you draw a line, okay, this is the formula of this straight line. Clear? This is the formula of straight line. So you can see, like, for straight line x came, for straight line x came. Now suppose if you write x square, okay, for x square you will get parabola like this. If you do x square, then it is like just beating this with the hammer and you are curving this. Suppose if it is x cube, all this has mathematical links. See, this much information you don't need, but for remembering, for make you remember, I am telling all this. This is straight line. Why we are taking differentiation of x raised to 5? Because they are not straight lines. If it is x cube, then this kind of shape will come. One more bend came. Correct or what? So x straight line, x square parabola, x cube again n kind of shape. Likewise, as the power of x increases, it will have different shapes. So for all that, just directly we cannot find the slope. We need the help of differentiation. That is done by taking small points, considering them as straight line, and from there they derived these formulas. We are not trying with the derivation how this came. I am directly giving you the formulas. Clear or what? Suppose another example. Suppose if I get f of t is equal to 4x, not x, 4t raised to 5. No, we will take the same function, 3x t raised to 5. See, this is a function of x. This is changing with respect to x. Now in x-axis, if we put t, then we get t raised to 5. How to do differentiation? Same as that. Now f dash of t is equal to d by dt of f of t. This is a function of time now, or function of t. T could be anything. Okay, generally we consider t as time when we study velocity, acceleration and all. Okay, so instead of t, anything can come here. So what we write here, d by dt of this one, 3t raised to 5. Now instead of x, here t comes. So we need to consider the power of 5. 3 we will put here just like that. 3 into, take this n this side. See, this is how it was. X raised to n, d by dx, x raised to n was xn, x raised to n minus 1. Here this is nothing but d by dt of t raised to n. So what it will come? N t raised to n minus 1. So what we will put here? Into 5 into t raised to 5 minus 1. So this is nothing but 15 t raised to 4. So instead of x, here t comes, nothing else. So anything can come. Okay. So we should understand the simple difference between these two. Note it down. Suppose if we get a function, see this, we will take, instead of f of t, we will take v of t. V of t is what? I will write f of t is equal to, here the function is nothing but velocity. So velocity is a function of time. Velocity varies with the time. How velocity varies with the time? Someone observed the vehicle or someone observed the object, they took a reading, they spent lot of time and doing all mathematical analysis, and they came to know that this is nothing but 3t square. Okay, so then someone is asking us to find, okay, then what is acceleration? Then what we will do? Acceleration is equal to v2 minus v1 by t2 minus t1. We cannot do here. What we will do? We will find slope. So a is equal to dv by v of t by dt. This is same as what? Delta v by delta t, or v2 minus v1 by t2 minus t1. Since when they were constant values, v2 minus v1 t2 by t1 was easy. So but now this is very short values and they are having some other shape. 3t square means what? It will have these kind of shapes and all. Okay, these kind of shapes. So when shape changes, we cannot directly find the slope. This is what actually slope. By finding the rate of change of velocity, we will be finding acceleration. Clear or what? So if someone is telling us to find, so I am not writing acceleration and all now. When we learn physics, we will go there directly. Simply someone asks us to find the differentiation of f of t. That is nothing but f dash of t. Okay, this is nothing but 3 into 2 will come this side, t raised to 2 minus 1. So I get 60. This is the differentiation of this. Okay. So another example. Suppose if we get, this is f of t. If I want f of x means function varies with the x. F of t means function varies with the time t or t. F of x is equal to 6x square plus 5x plus 2. 5x plus 2. Okay, leave this. Before that, we will do like this. F of x of 2. F of x of 2 is what actually? If this is x, this is y. So this y is nothing but f of x. Y is what is f of x. Both are same. When we write v of t, where we write velocity, we will write here. That is nothing but time. X-axis we will be putting time. Here we put velocity. Likewise, this is y, this is x. Okay, y changes with the x. So this function f of x changes with the x. That is what the meaning is. So when I write 2, at x is equal to 1, what is the output? What is the output? See, when f of 1 is given as 2, here I don't have anything to substitute. When if it was 2x, I will be putting 1, I will be putting 2, so I will get 2, I get 4. Likewise, if it is 2, I don't have x to substitute 1, so I will be getting 2 itself. F of 2, when I substitute the value of x, again here no x, so again 2, so it is a constant value. So what I get when x is equal to 1, x is equal to 2, x is equal to 3, everywhere I will be getting what value for y? I get 2. So this is a straight line. This is a straight line. So find the slope of this. Slope is nothing but tan theta. What is the angle here? Theta is equal to 0. So this is 0. Slope is 0. So same way, if we take f of x is equal to 2, and if we try to find f dash of x, that is d by dx of f of x is nothing but d by dx of 2 is equal to 0. So differentiation of constant is 0. Differentiation of constant is 0. Why this is 0? Graphically we have seen slope is 0 here. x2 minus x1 is equal to 0. y2 minus y1 is equal to 0. Not x2 minus x1, y2 minus y1 is equal to 0. So here what is x at this point? What is x? 1. What is y? 1 comma 2. At this point, if we take this point, what is x here? 3. What is y? Y is again 2. So look here, y2 minus y1 by x2 minus x1 is what is? Slope. So y2 is what? 2. y1 is what? 2. So this is 3 minus 1. That doesn't matter because numerator it came 0 already. So in short, what we are saying is differentiation of constant is 0. Differentiation of constant is 0. Okay. So d by dx of constant is equal to 0. D by dx of 5 is equal to 0. 5, 2, 10, whatever, any constant value, d by dx will be 0. Okay. Suppose if we get f of t is equal to 3t square plus 2t plus 5. Then we are asked to find the differentiation of this. So f dash of t is nothing but d by dt of 3t square plus 2t plus 5. So this is equal to, when you do differentiation, 2 will come here. We need, so see, we got here 1, 2, 3 parts. No need to worry, differentiate it separately, but then put like this. So first I will differentiate this. So for that 3 will be coming here into 2 will go here, no, n t raised to n minus 1. So n will come here. So 2 came here, t raised to 2 minus 1 plus, don't disturb 2 there, 2 let it be there, into t raised to 1 minus 1, no, 1 minus 1 here, t raised to 1, n is 1 here, plus 5 t raised to, see, then no need to worry, already we know differentiation of 5 is 0, so directly we will put 0. So here this is nothing but 6t plus 1 minus 1 means t raised to 0 is nothing but 1, anything raised to 0 is 1, 6t plus 2, this is the answer, 6t plus 2. Note it down, dear students. So see, differentiation of sine, differentiation of exponential, differentiation of log, everything can be studied here, but I am not going into those functions now. We will see it in the another session, okay, maybe next one, or maybe when time comes. Everything if you study, you need not get confused. So watch this video again and again and make these concepts thorough. Okay, thorough. When we do the problems in physics, you will get better clarity. Okay, so one more problem I am doing. With this we will wind up the session. Suppose if we get like g of t, okay, function can be called as f of x or y, whatever we want we can call it, g of t, or simply I am giving y is equal to 5x square plus 3x plus 2. So when you differentiate dy by dx, when you differentiate, what you need to do? Put the 2 here, directly do. Okay, I wrote there in a detailed way just for understanding purpose, but when you do, you can directly write. So 2 will come here, directly write as 10. 2 minus 1 is 1, so x raised to 1, keep it there, plus 3 we can write, nothing is there, so x, d by dx of x is nothing but 1, so keep it there. This is the answer. Directly do without doing all this, but initially you can do all the steps, but finally after, when we get fluent with all these formulas, directly we will do like this. Clear or what? Note it down. Okay students, so today we saw just the introduction of differentiation. Okay, just the introduction of differentiation. So calculus is a mathematical tool. In that, one part is differentiation, Another part is integration. Another part is integration. Okay, differentiation and integration. So differentiation is nothing but finding the difference or finding the slope or finding dy by dx. Dy by dx. In y-axis anything can come. In x-axis anything can come. Generally, mathematical language we say, because that axis name is y, this axis name is x. So dy by dx. So just finding the slope. Okay. Straight line we will be finding slope y2 minus y1 by x2 minus x1. But when it gets complex, what we do, we will take two short points and we will consider that as straight points, straight line, and we apply, instead of delta y by delta x, we put dy by dx. Okay, so differentiation formulas are there, different functions will be there, and different functions has different formulas. Okay, so we just saw the polynomial functions today, how to differentiate them, and differentiation can be done with respect to x or with respect to time or with respect to anything, but most of the cases our differentiation will be with respect to x or time, t. In mathematics we will be studying mostly all of the differentiation with respect to x. In physics, when it comes, it is real application. The application of mathematics will come in physics, right? So there we will be studying with respect to time, or sometimes with respect to x, or maybe with respect to anything. Okay, then and there we will discuss that. So the topic which we have studied is actually 3 to 4 chapters in mathematics. So whatever is necessary for physics only we will be studying. So for the next topic, whatever small things which we require, we have covered it today. One more session will be there for calculus, and with that we will be able to deal the max in motion in one dimension, and other functions like exponential function, sine function, log function, what are their differentiation, that we will see in the another session. Okay, fine students, so watch this video carefully, and if you have again doubts, then watch it again and again, and further if you have doubts you can approach me, okay, and we will clear off the doubts. Okay, thank you, all the best, goodbye.